All right, for number one, air is being pumped into a spherical balloon. So we've got our balloon here. At a rate of 4.5 cubic inches per minute. Okay, the rate is 4.5 cubic inches per minute. All right, so it obviously tells us that it's a rate, but what we look for rates are measurements per time. All right, so that tells us it's going to be a rate. Well, in this case, we have cubic inches per minute. So what rate do you think we're talking about here? Heard someone say, what was that? Say it loud, say it loud, yeah. Volume. All right, so the change in volume with respect to time. Because volume is measured in cubic units. So dV/dt is 4.5 cubic inches per minute. Now, we have to always take into account, is it going to be positive or negative rate? If the variable is getting bigger, then the rate's going to be positive. If the variable is getting smaller, the rate is negative. So here, air is being pumped into the balloon, so that means the volume of the balloon is getting larger. So this rate is going to be positive. If we switch this problem around and said that volume was leaking out of a balloon, then the volume would be getting smaller and this rate would be negative. So you need to kind of take that into account in these problems. It says to find the rate of change of the radius, so we're trying to find dr dt when the radius is 2 inches. So we're trying to figure out what variable to use, what equation to use to do the derivative of. So here we're talking about volume of a sphere. We can use that formula. Volume of a sphere is 4/3 pi r cubed. So that relates our variables that we're dealing with here. We're going to go ahead and take the derivative of both sides with respect to time to see how everything's changing with time. So derivative of volume with respect to time is just dV/dt. Over here, these are constants, the 4/3 pi. We're going to bring that 3 out in front times 4/3. We get 4 pi times r squared, and then we have to multiply by the derivative of r, which is dr dt. And once we do the derivative of both sides, then we're just substituting all the values in that we know to find what we don't know. So dV/dt is 4.5 equals 4 times pi times 2 squared times dr dt. That's what we're trying to figure out. So 4.5 equals 16 pi dr dt. And we just need to divide both sides by 16 pi. Now be careful when you do this in your calculator. You need to make sure that you have that 16 pi in parentheses. Right? If you don't have the 16 pi in parentheses, calculator is going to do 4.5 divided by 16, get that answer, and then multiply it by pi. We're going to round this to 3 decimal places, just like the AP test. So we end up with 0.09. So dr dt comes out to 0.09 inches per minute. You want to make sure you label your answers. So we're talking about radius, that's just measured in inches. So this is going to be inches per minute. I did say 3 decimal places. And it would have rounded to 0.090. I'm not going to bother writing the 0.